and in today's video, we're gonna go over chemical bonding and molecular geometry. I said I would never do a chemistry video again, but my most popular video was a chemistry equation video, so I don't know. I could be doing so much other things than doing this, like Roblox. I could play Roblox instead of this. It's fine. Okay, so, okay, I'll just do it. Okay, so we're gonna go over the nature of bonding in chemistry. I don't hear anyone clapping. Okay, so these are the two most common bonds. I mean, the two most, easiest bonds to understand is ionic and covalent bonding. So ionic bonding involves the complete transfer of electrons from a metal to a nonmetal, and this creates a crystal lattice held by electrostatic attraction. So think about, let's say you have your friend, right? He has a cookie, right? But let's say you want to bond with him, but you want to take his cookie. So you... Is it raining outside? Let me check. What's that noise outside? Okay, so, and then you take the entire cookie and then you bond with him. But then with covalent bonding, this involves the sharing of electron pairs between nonmetals to achieve a stable octet. So let's say your friend has another giant cookie, but then you want to bond with him, but you only want half a cookie. So you take half his cookie and bind with him and form an octet, and now you're covalently bonded. It's like a marriage made happen. I don't know why I'm so happy about chemistry. Okay, so we have the atomic structure right here. Then you can pause the video and look at this. These are really good figures that teachers don't show. They gatekeep it, but I'm ungatekeep it. I got the key. I'm like the key. I'm the key in the vault, in the back in the train. I don't know. Okay, so now we're gonna go over metallic bonding. So there's a sea of electrons, and valence electrons are delocalized, which moves it freely through a lattice of positive metal cations. And then also conductivity is free moving electrons allow metals to conduct heat and electricity with extreme efficiency. And then finally, these are characteristics of metallic bonding. Malleability, where the atomic layer can slide over each other without breaking bonds, and this is thanks to its flexible electron seat. Now we're gonna go over visualizing electrons. Seeing is to believe. Pictures are worth 1,000 words. Yeah. Okay, so here is a Lewis dot diagram. It's a little shifted, it's a little off, but okay. To draw, this is like a simple Lewis dot diagram. There's a lot of other Lewis dot diagrams that I had to learn for chemistry, and that's why I did not like chemistry. But okay, first you gotta count the valence electrons, and then you gotta arrange the atoms with the least electronegative in the center, and then use pairs of electrons to form the bonds and distribute the remaining electrons to satisfy the octet rule. So you put the valence electrons, you start from here, and you go this is clockwise until you run out. And then hydrogen only needs a duet of 2 electrons, by the way. And yeah. And then we're going to go over the VSEPR theory, which predicts the 3D shape from 2D structures. So first we're going to do minimizing repulsion. So the concept is that valence shows electron pair repulsion theory states that the electron domain bonds or lone pairs will stay as far apart as possible, and then the lone pair versus the bond pair is that the lone pair occupies more space than the bonding pair, and it compresses adjacent bond angles. So here's a representation of this. It's pretty cool. This is a pretty short video. Oh, bruh. Where's the... I already called during the last two videos, and I'm pretty sure I would give an answer to one of the questions I asked at the end of the video, but I just never did it. Yeah. Oh shoot. Okay. I don't know, but I guess I can just say the CO2 linear and BF3 triangular planar is two domains around a center atom, and like CO2, the C right here, O, and like that. And then a triangular pillar is like the three domains around a central atom with 120 degrees. So this is like straight, but this is like triangle. It's a triangle. Okay, now finally we have some. So now we have the 4 electron domains with a tetrahedral. I'm gonna do a special video about tetrahedrals, but there's 4 bonding pairs, an example methane CH4. Then we have the bent, even more, of 2 bonding pairs plus 2 lone pairs of example water H2O right here, right here. So take it just anytime, make sure to pause the video and closely look in depth in the figures. Yeah. Hold on. Let's what should I do? Because we still have a good amount of time. So I could scroll, but then what would you do? Or you could scroll with me. Ho ho ho, green giant. Okay, hold on, let me think of something. I'm gonna think of something. Let's see, what can we do? Hold on. Oh, let's just go over the summary really quick. So the molecular shape summary is that let's say there's 2 domains, then it's linear with 0 lone pairs and 180, and then it goes from 3 to 4 to 4 to 4 with triangle planar, tetrahedral, trigonal, pyramidal, and then bent, and then the lone pairs only are with the triagonal pyramid and the bent ones, and these are the angles right here. And then we have the electronegativity and bond polarity graph. Oh, here's a picture of the chemistry table of elements. Yo, do you remember the song? I think I still have it. This is the periodic table song. There's hydrogen and helium, lithium, beryllium, nitrogen off through the air, carbon, something, oxygen, so you can breathe in something, magnesium, fastest magnesium. This is the periodic table. Noble gases, noble hydrogen and alkaline and metals actively something. Okay, this is aura loss, bro. What the I'm just saying something. Anyways, here's the table, and this shows the ability of an atom to attract shared electrons, and this determines the polarity of the bond. As you can see, it's like an almost exponential curve, but very slowly. And yeah, so that's a very basic video about chemical bondings. There's a lot more, like van der Waals, hydrogen bonds. There's also let's see, hydrogen bonds. Uh, there's a lot of other bond. I had to do ed puzzles, and I wrote out like like uh two whole notebooks full of notes, right? And I had to upload it to this website. But then if I forgot to upload it, then I would just get points off. But I swear, there's one time I did upload it, but then deleted it by itself, and it wasn't my fault. But then the teacher still took off a couple points. I'm like, damn. So if I ever become a teacher, I'm gonna make every student do 50 ed puzzles a night. 50, and then they have to turn in the notes chronologically ordered. No, I'm just kidding. I'm gonna be a chill teacher. But okay, here's like some of the sources I used. yeah, as you can see, a periodic table increasing with, yeah. Oh yeah, the valence I can do a whole video about the periodic table in another video, but yeah. But I hope you learned something today. I know I didn't because I already knew this, but I hope you have a good day. Bye.